So today we're going to deter a little bit from the normal video and go with more of a use case around multi-cloud defense. What we're going to talk about today is how to take a website. This particular website will be hosted through S3, through an S3 bucket in AWS. But that S3 bucket in AWS is currently fronted by, let's say, CloudFront, which is an AWS CDN network. So what we're going to do is figure out how can we run multi-cloud defense in between CloudFront and the hosted S3 bucket so that we could provide some next-gen firewall type capabilities around it. So let's take a look and see how we can do this today with multi-cloud defense. The first thing we'll walk through is a quick diagram. Picture speaks 1,000 words, right? So as the traffic flow is today, and I'll just kind of draw, some faux arrows here. Typically a client would come into a particular website, it's going to hit CloudFront, and then CloudFront without multi-cloud defense involved would go straight to the S3 bucket as what they call an origin. So rather than this and just being able to provide some of the kind of rudimentary protections that are available like WAF through CloudFront today, what we want to do is set ourselves multi-cloud defense kind of in the middle of this flow. So rather than going straight from CloudFront to the origin that's S3, what we want to do is go from CloudFront through a multi-cloud defense ingress gateway and then to the S3 hosted website. To do that, we'll have a couple of things in place, and I will go ahead and say I have deployed currently the security VPC. That may not be my current CIDR. I just kind of whipped this diagram together because I thought it would benefit everybody. But what we did was we deployed in a single availability zone and ingress gateway. That automatically, as part of the deployment, is going to have a public-facing NLB, so we'll kind of go through some of that stuff. But what we want is to have this website accessible as a client comes in through CloudFront. It's going to send it to the elastic load balancer that we deploy alongside the ingress gateway. It's going to spray traffic through our multi-cloud defense gateway and then finally to the S3 hosted website. So to do that, we'll have a couple of things and I'll go through those as we deploy. So let's take a look first and investigate what is currently in AWS. So rather than going through the instances first, what I want to do is show the S3 bucket. So this S3 bucket is actually called hikeronatrail.com. That's actually a domain that I own, and it does have to match the incoming host header or SNI of what my client, in this case my laptop, is going to be pushing through the web browser to try to access that site. Everything is going to be landing ultimately on this index.html. And what I've done to kind of populate this, and I will put this in the description for this video, is I just cloned this gentleman's GitHub repository, and then I dumped the contents of this website folder into my S3 bucket. It's basically a password generator. It's fairly rudimentary, but it does what it needs to, and it provides us with an endpoint that we can test against. So this S3 bucket, we will mess with a couple things, but one thing I want to point out is it's a pretty basic S3 bucket. I do not have static website hosting turned on, so that's currently disabled. It will stay that way. And then permissions wise, what we want to do is we do not want this publicly accessible, as most organizations don't. We want to be able to access this privately, and we're going to do that through the use of what we call a VPC endpoint, which is think of it like an interface that we're going to drop into the VPC. So in this case, this little VPCE that you see here, this is that VPC endpoint that we'll be accessing the S3 bucket through. And what that does again is it just allows us to access that S3 bucket privately rather than having to access it over, like the internet. We will adjust the permissions, and you can kind of see how we'll lock that down. So I've already kind of put in the structure that we'll use here, where we're going to allow access to this bucket for GET functions. And we'll go through this when I actually update it, but it's only going to be accessible through something coming through that VPC endpoint. We'll show off our current multi-cloud defense gateway. So you do see we have the ingress gateway that's currently in here. Nothing real special about it. It does have public IP addresses that we can use that for testing as well. That is front-ended by that load balancer that I pointed out earlier. So we see the Cisco MCD load balancer here. Again, this is, if you looked into the semantics of it, what it's doing is it's basically going to be listening on a port that we defined through our policy, and then it's going to be forwarding. This is kind of neat. They added this resource map. It's going to be forwarding to the target group that is our multi-cloud defense gateway. So what we're going to do is walk ourselves through the configuration of this and how we can kind of achieve essentially what we've depicted in this diagram, where everything flows through multi-cloud defense to get to this S3 bucket contents. So one of the first things we actually need to go in and do is create our VPC endpoint. I don't have that in place today. So I'm going to go into VPC. We will go into, if you scroll down over here under private link and lattice, we'll go to endpoints. We can see there's only one in here, so I'm going to go ahead and create one. We're going to call this CloudFront to S3 Hiker on a Trail, AWS services, and then I like to just search for S3 here, even though it's at the top. And you have a couple options. You have the S3 interface option, which it works. I've tested this as well. The gateway option, I believe, is ultimately a little more frugal in terms of cost. There are some greater costs associated with the interface-based endpoint. So I'm going to go with the gateway. I actually think it showcases something pretty neat in terms of access. We access the gateway S3 endpoint through the route table, whereas the interface is going to be done more recursively through like private link DNS that's automatically set up as part of that deployment. So I'm going to select the S3 gateway. We will point it at our current, this is actually our security VPC that we've deployed. So this MCD CloudFront project VPC. And then within there, what I want to do is make this accessible from my data path route table. So I'm going to go ahead and select that data path route table. And what this is going to do, and I'll actually go, let's actually pivot over there so I can show something. So right now, this route table is pretty minimalistic. So if I just filter on CloudFront, we look at the data path route table, and I go to routes. Notice there's only a default and then the VPC, so the kind of VPC supernet route. So when I go through this and I check this box, what it's going to do is it's going to put a route in that route table for the S3 service that's pointed towards this VPC endpoint. Just does it automatically. Now I could lock down who could access this VPC endpoint with a custom kind of policy within here. I'm just going to go ahead and allow full access. So it's going to be locked down through Multicloud Defense. And we'll click Create Endpoint. Now this actually creates fairly quick. As you can see, it's already available. The interface endpoint takes a couple minutes, like probably 3 to 5 minutes typically. But what I want to do is I currently want to take the VPC endpoint ID. And while I'm thinking about it, I want to go over here to S3. And within my bucket, under the permissions, I want to update my bucket policy with this new VPC endpoint ID. So we'll clear this out. So essentially, I'm restricting access to this bucket to only flows that are coming from this VPC endpoint. So we'll go ahead and save that. All right. And if I go look at the route table now, so we'll refresh it, reselect it, look at the routes, and you can see the route. So it puts in a prefix list for essentially all of the S3 public IPs, and then it's saying the target's going to be the VPC endpoint. So that's how we're actually going to route traffic coming from the Multicloud Defense Gateway. Imagine as it's proxying this flow, right? The client session to hikeronatrail.com is ultimately going to hit this gateway, and we're going to terminate a client to server connection between these two devices. Then on the back end, we're going to instantiate a new connection from the Multicloud Defense Gateway to the S3 bucket, but that's going to traverse this VPC endpoint. So again, everything is going to be coming from Multicloud Defense through the VPC endpoint to the S3 bucket. So now that that's set up, we should walk through and go ahead and get the CloudFront stood up. So I'll go ahead, let's click on CloudFront. And before we do this, I should be able to test. I've actually got a Windows box. I've got I've got this Windows box, and actually I think I have, yeah, I do. I have a session open to it already. So we should be able to access that S3 bucket the same way Multicloud Defense is going to access it through that VPC endpoint. So let me go to Hiker on a Trail. So we'll go to the S3 path for that, which is the bucket name .s3.us east 1 Amazon AWS, and then I'm accessing index.html. So we'll hit enter there, and we can see we get this. So password generator, so I can go through. So we are accessing that bucket directly through here. It looks like I'm using port 80, so let's try it on. Make sure that bucket is serving encrypted. Yep. So both HTTP and HTTPS are accessible from within that VPC. So I know Multicloud Defense, if I was on that gateway through SSH or what have you, I should be able to do the exact same thing this Windows box is doing. So the next thing I want to do is create CloudFront, which is essentially this content distribution network component that AWS uses. So I'm going to be creating this now. So let's go to CloudFront. We'll go ahead and say create a distribution. So the first thing it asks is like, what's your origin? Origin to CloudFront is essentially where are you going to be serving traffic, or like basically this service from. So even though it's S3, and this would be how it was originally configured, right, was to serve traffic directly from S3 through CloudFront. Instead of going through S3, or directly to S3, I should say, I'm going to go to this elastic load balancer that is Multicloud Defenses. So this Cisco MCD cloud with 2 U's, NVUAJT. So just make sure that's the same one. Yep, it's the same one. So I'll go ahead and select that. What it does is it automatically picks up the DNS name of that. You could pick or specify your protocol. I'm just going to say match viewer, which means, if they come in on port 80, allow that. If they come in on HTTPS, it's 443. Minimum origin SSL protocol, I'm going to leave that at TLS version 1.2 right now. Origin path, I'm going to leave blank. Name, I'm going to leave the same. So again, that's the DNS name of this dude. And then default cache behavior. This is pretty important because what we want to do is we want to make sure that as a client initiates a session to hikeronatrail.com, we want that to pass through CloudFront, that host header or SNI, go through our network or elastic load balancer and get all the way to Multicloud Defense. So within Multicloud Defense, it's going to be expecting to receive the actual host header coming from the client. So we don't want to modify or change anything. So what I'm going to do is allow just get and hit. We're not going to be doing any like API actions against this. It's basically just serving up a website. So these are going to be our allowed methods or verbs. We are not going to restrict viewer access, but what we're going to do is make sure that this all viewer origin request policy, which means we're going to forward all parameters and headers in the viewer request through CloudFront. If you take a look at this, there are many options here. We're not going to explore them all here. To be honest with you, I don't know what they all do, but we're going to make sure that we're passing all those host headers all the way through. Beyond that, I don't think there's anything else. I'm not going to enable any security protections from CloudFront. And then I'm going to say use all the edge locations. SSL certificate. This is kind of important. Like, how do you, for the SSL or HTTPS based sessions, what are you going to present to the client? I have uploaded some certificates to ACM for this, so some certs that I because I own the domain hikeronatrail.com, I went ahead and created a certificate for www.hikeronatrail.com as well as the root domain, and I uploaded those to ACM. Now I had generated one. Let's actually, good point. I should figure out which one within certificate manager here. One of those is imported and one of those is generated. So I issued the one that ends in 6.8, and then the 2.3.0 is the one I want to use. So let's go to here. We'll pick 2.3.0. I'm going to leave everything else the default. I'm actually going to uncheck HTTP2. Default root object is actually index.html, but I'm going to leave that blank because I want to prove a point here, and I'm going to create the distribution. One of the things I forgot to do earlier, and I wanted to come back and reiterate that it needs to be done, is within the CloudFront distribution, there is this concept of alternate domain name. So meaning anything coming in maybe by a CNAME record pointed towards this domain distribution, we need to specify. So what I did was I went into my distribution node, I clicked edit here, and I added the hikeronatrail.com as an alt name for this distribution. So that's important as you go through your CloudFront configuration to make sure that that's done. And just note that it does trigger a redeployment of this CDN network node. Now this will take a minute, but as you notice, it gives us the distribution domain name now. So I'm going to copy that. And in another window, let me pull up. What I'm going to do is change my CNAME record for hikeronatrail.com to this new CloudFront address. And I'm doing that now because I know as it deploys, it's going to take it a minute to actually deploy this. You can see the last modified is deploying. So while that does that, we can do a couple of things, right? We obviously can't access it right now through there because the CDN's not completely built. But what we can do is we can go build the Multicloud Defense policy framework to essentially support that. We need to do a couple things. Walking through the diagram, we need to identify the backend address that we're going to be proxying traffic to. So in this case, it's going to be the FQDN of the S3 bucket. So I am going to go into Multicloud Defense. We'll go to policies and we'll go to addresses. So addresses, again, they're like synonymous with, object groups or network object groups, but I want to build two of these. I want to build one for the reverse proxy target. So this is going to be our hiker on a trail S3. And I'm going to say this is going to go to an IP or FQDN. And actually the FQDN I want to use is this. So I'm going to go ahead and copy that. And we'll paste that in. So hikeronatrail.s3.useast1.amazonaws.com. And we'll save that. The other address that I want to create, because what I don't want is I don't want a client coming directly to my public-facing NLB. This is not what we want. We want to force these clients to go through CloudFront. So what I want to do is restrict who's able to access this website to only flows coming through AWS's CloudFront service. And one of the very easy ways we can do that is by going in and creating a source and destination object group. So I'm going to call this CloudFront Global. I'm going to do this as none of these, but rather a service endpoint. It's going to be from my AWS account. And this service is actually going to be CloudFront. And instead of picking a specific region, because this is globally served, I'm going to pick global. What this does is it actually goes out to Amazon and it picks out what we call within Multicloud Defense, the sub-objects for this. If I take a look at this again, what you see is all the CIDR blocks that essentially CloudFront nodes are hosted from. So these are all the places we could expect or should expect flows to be able to come in from, which is nice, right? Now we're able to essentially or ostensibly force that traffic to come in through CloudFront before we serve it. So now I have my source and my destination. I need to identify my service. What ports and protocols are we going to use? So within here, I'm going to go to services. Now we want to go in and build our service, which is going to be essentially how we identify the port and protocol and what we actually want to proxy through Multicloud Defense. So I'm going to go ahead and say create. We are going to do a reverse proxy. Let's go ahead and say this is going to be CloudFront to Hiker on a Trail. Our listener decryption profile, this is important. And actually, I'm going to pivot out of here for just a second, because the decryption profile is comprised of what certificate we want to use and then what ciphers we want to use alongside that. So the certificate I've actually imported in here is hikeronatrail.com. You can see it's from 0SSL. And this is very important when kind of coexisting with CDNs, is you not only need to present your certificate, but the entire certificate body and chain. And if you don't have the entire chain, you're going to end up getting a 502 back from like CloudFront in this case. Now, when I went through 0SSL, what they did is they sent me 3 files, right? The CA bundle, the certificate, and the private key. So I actually had to combine the certificate and the CA bundle before I could get through CloudFront, right? That's what had to be presented to CloudFront. So what I ended up doing was I copied the certificate contents and I went into my CA bundle and I essentially added that certificate content on top. And it does have to be in this order. Some of the trusted root cert authorities will actually already give you a combined file. This one just was not, but just be aware, you have to present the entire certificate chain back to CloudFront, or you'll get a 502 as you try to go through there. So when I imported this, I made sure to include that entire cert body. This, I'm actually just going to, there was a default profile in here, this sample TLS profile ingress. So what I did was I just went in and used Hiker on a Trail rather than the built-in cert. This included, all the common Diffie-Hellman, all the ciphers that are just kind of basic ciphers. If you need any additional support, you can go through here and check these. There is a website out there. Let me see if I can bring it up here. Let me copy this. If you need to kind of cross-reference, there is a website for CloudFront that gives you all of the supported ciphers. Just make sure you have a couple of these so that the negotiation actually goes through. But I'm going to be using this encryption profile. So we'll go back to the services. I will create the reverse proxy. We'll call it CloudFront to Hiker on a Trail. So the listener decryption profile will be this sample TLS profile ingress. I'm not doing mutual TLS, so I'm not going to worry about the client CA. We're going to do TCP 443 to 443 on the back end, but we're going to do decryption. So I'm going to have HTTPS as the proxy protocol. And then the backend target for this is going to be Hiker on a Trail _ S3, which is that address, the S3 FQDN that we set up earlier. Now it's important that we should be aware there could be multiple websites being served through here, or services on 443. So what we can do to ensure that traffic hitting this specific rule that's going to this bucket is coming in on a specific SNI, we can type those in here. So I'm going to say hikeronatrail.com, and then we can even do the www.hikeronatrail.com. And with this, we're essentially doing some SNI-based routing, saying anything coming in on these SNI or host headers are going to get proxied to this backend. So we'll click Save, and then we can move on to the rules. Now, please forgive me, as I've recorded this video about 4 times now, and every time I do it crashes, and for some reason it's not recovering my audio and video for this portion. But I was going through the configuration of this rule. I'm not going to do it again, but what I did, and I'll kind of walk through it, is I set up a rule within my empty rule set that was a type reverse proxy. I leveraged the service, which is the 443 with the SNI based routing. I am making sure that it's being sourced through the CloudFront nodes. That was the address object we set up. And the backend destination was the Hiker on a Trail S3 bucket address object that we specified the FQDM for. We allowed and logged it. I saved it. So this has all been pushed out. Everything looks good. I was also showing that within AWS, once we did that, the load balancer that is provisioned dynamically gets instantiated with a listener on the port, right? This port correlates to the service within that rule we set up. If we were to do another service with like port 80 or NTP, those would start showing up as listeners dynamically within here. The 443 is being essentially forwarded through the Elastic Load Balancer, right? The target group that is currently just serving through one node. But the outcome of this is that, CloudFront is fully deployed. So the distribution is finished deploying. The rules are good within Multicloud Defense. So what we should be able to do is navigate to hikeronatrail.com. Make sure this is HTTPS. And we look at index, and we see the website, right? So we're actually serving up the contents of that S3 bucket. Now, if I were to go back one level and try to access the root of the S3 bucket, this was not encompassed in our policy, right? Our policy allowed anything within the bucket, but not the root of the bucket. So I would expect, and we do see an access denied message here. So that all looks great, right? That's exactly what's supposed to be happening. But what is it showing within Multicloud Defense? So let's go to Investigate and then Traffic Summary, which should show us the front end and back end connections. So we do actually see quite a few sessions coming through here, right? We'll take a look, walk through this. Everything's coming through that one instance right now. So 7C, we see the FQDN. We look down through here, we can start to see, hey, this is running a GET using HTTP version 1. We do see the X-forwarded headers. So these are actually my IP addresses of where I'm sourcing this traffic from. This is the destination IP. And we can see the front end connection that is fully set up. And then we should see the back end connection. And so we do see this backend connection is also fully stood up. What threw me there for a second, this is actually the backend connection through the S3 gateway versus what I've done previously was through an S3 VPC endpoint that was the type interface, and that actually gets an IP address in this case, the same subnet as I expect to see the gateway from. But this is essentially showing us that we're getting a full backend connection and a full setup front end connection. And everything from a transmission point is bidirectional and obviously working as intended. We could go a little bit further into these logs if we wanted. We could look at all events around these. And this just gives you a little bit more detail into what's happening at the TLS level, as it progresses through our security pipeline, what TLS versions were negotiated, so on and so forth. But at this point, we have full bidirectional communication between ourselves as the client through CloudFront, and we are getting the contents of an S3 bucket, and everything is working. So again, per our diagram, our client's initializing a connection to hikeronatrail.com. We are actually, because of my CNAME record within my domain registrar, it's pointing this hikeronatrail.com to CloudFront. CloudFront is set up to not only listen to that alternate domain name, but forward it to the Elastic Load Balancer that is associated with the Multicloud Defense Gateway, which processes and reverse proxies that traffic, ultimately through a VPC endpoint that is a type gateway to our S3 bucket. And again, a nice kind of cohesive security solution for securing, whether this is something that you guys have and currently deployed and we can operate as a brownfield, or if you have yet to implement it, we could implement this as a complete greenfield solution to serve up and filter this traffic.
As always, if you found this video useful, keep a keen eye on this channel as we will be releasing more and more content around the deployment and uses of multi-cloud defense and how you can use it to protect your cloud infrastructure. Thank you for watching. We look forward to seeing you in the next video.